address is less than limit register. This will be checked here. If it is yes, then it is this, then this relocation register is coming and they are getting add the logical address and the relocation register will be added so that you can get the physical address that will map the main memory. And if the condition is false, then the same error will be shown there, that is addressing error. Okay, that we have already shown. Fragmentation, about fragmentation I have already told that there are two different types of fragmentation. One is the internal fragmentation and the other one is the external fragmentation. So what is that I am showing in the diagram? You can see that this diagram here. So suppose you have some jobs that are kept in the memory. Initially we have the operating system. So from 0 to 300 the values are shown, no, not 300, up to 299 the addresses is for the operating system. Okay, from 300 to 499 it is for the job 1, from 500 to 599 it is for job 2. Okay, then 600 to this 1000, this is blank, this is actually you can allocate some process there. Okay, and then this 1000 to 2000 1000, sorry, 1199 up to this there will be job 3. So what we are trying here, we may do this thing that we may keep the processes. Suppose this thing is blank from 600 to 1000. Okay, so that means 400 up to 400 values are blank here. So we may keep a process that is the size 200 size. Okay, job 3 we can keep there. So up to from 600 to 800 will be reserved for job 3, that we have done here. Now if we can merge them, if we can merge the location up to, so yeah, this particular location, so job 3 is actually switched from this location to the 600 to 800 location. That means from 800 to this 1200 this location will be free. That means 400 size process or job can be stored there. So we can store the process job 4 that is actually having size 400, that was allocated in the location 1500 to 1900. Okay, that we have stored in this location. Okay, and remaining location is actually freed here. Okay, same thing we can do also, that is we may take job 4 previously and then we may take job 3. So they have done in the third diagram. You can see job 1, job 2 is fine, job 4 they have taken first and job 3 they have taken in the later. Okay, or we can do that we may keep this particular location from 600 to 1500 as the reserved location, and then from 1500 to 1900 in the job 4 and 1900 to 2100 in the job 3. But these things does not happen because of that, because we cannot allocate them, because the internal fragmentation is telling that if you have fixed size blocks or fixed size partitions, then suppose you are given, suppose you are just given the allocation like 0, then 200, then 400, then 600, then 800, and then 1000, like this. So partitions are given in that way. Okay, now if you are going to store a process that requires 100 size, so you have stored that one in a particular location, but as they are the fixed size location, you cannot change their size dynamically. Okay, so due to that one, if you are not able to extend the size, any process that is more than suppose 100 you cannot store in the particular location, that is free location. So that free location, suppose this particular location, you see that from 300 500 this location, if a process size is suppose 100, so you are just storing from 300, from this 300 to 400 location. but from 400 to 500 location will be empty because because if any other process of having size 100 is not coming there, suppose there is no other process that is size 100 available there, so you are not able to keep in this particular blank space, therefore this space will be actually waste. Okay, that will be your waste, and that is called the internal fragmentation that I have taught in the class also. And what is the external fragmentation? This external fragmentation is telling that if you have the processes, suppose you have kept the processes in the memory, but suppose you have some other processes that are to be kept in the memory, and if you have some wastage or in the memory, that like your some internal fragmentation happen, due to that some waste memory is there, you are not being allowed to merge them to get the a complete space so that you can keep the process over there. So why they have done this thing? So why they are telling these things, that they are actually merging the space, this thing is merged, this thing is merged, this thing is merged. Why they are doing this thing? This is possible by the process called the compaction, this compaction. Okay, so if this thing happens, that external fragmentation is occurring, okay, this external fragmentation can be resolved by the process of compaction. Okay, you can compact that spaces, so that I am telling here, you can see that shuffle the contents of the contents to place in all free memory together in a large block. Then compaction is possible only if relocation is dynamic, okay, and is done in the execution time. So that you can see that this is called the compaction, means from this particular location, from this particular figure, if you are getting this one, getting this one, or this one, or this one, these are actually compaction. So all the allocated locations are kept in one side, all the free locations are kept in another side. Here also same thing, here also same thing. The difference is there. In this case they have taken job 3 first, job 4 later. In this case they have taken job 4 first, job 3 later. And in this case they have intermediately they have kept the space, and job 4 and job 3 is kept at the end depending on their size, because job 4 requires 400 and job 3 requires 200. So 600 is kept for them, and from this 16 from the 600 to 1500, this space is kept blank for any other jobs to come, and they will be allocated there. Okay, this is done by the compaction. So the internal fragmentation and the external fragmentation is understood to you. Now we are going to the part. So now this part, this paging part, I will tell later in the next class. Next Thursday, I will tell you about the paging. From paging, we will start uh, in the next class. So in today's class, if you have any problem, you can tell me. Okay, otherwise I will conclude the class. So up to this thing we have to teach. Okay, these things are very important. This page replacement algorithms are very important, that I will teach in the class also. Some algorithms are there that I will teach in the class. So in today's class, if you have any problem, you can tell me. That is just up to paging. Up to paging. Any question, anyone? Up to this PDF? Up to this
স্যার এখানে 5 মার্কের কোশ্চেন আসতে পারে?
yes, 5 marks question কি আসতে পারে বলে দিচ্ছি এখান থেকে, হ্যাঁ অবশ্যই ভালো কোশ্চেন করেছো। ফার্স্ট, হোয়াট ইজ মেমোরি ম্যানেজমেন্ট ইউনিট? ওকে, describe how memory management unit works, this thing. Next question may come like this, that what is the difference between fixed size partition and variable size partition. Okay. Then this question may come, what is the function of relocation register and how the mapping is done? Explain external fragmentation and internal fragmentation with suitable example. Then what is logical address space and physical address space? What is the function of base register and limit register? These questions only up to this part. Okay. Now after this, there will be some other things that I will teach and I will tell the questions.
Okay, sir.
So,
Thank you.
so any more clearance is required? Okay.